In this video today, we are going to be looking at the graphs of the sine and the cosine functions. The first one that we're going to look at is the sine function. The function notation for the sine function is f of theta is equal to the sine of theta. The graph is represented down here in the red curve. The y-intercept of the sine function is always the origin, 0, 0. The x-intercepts are multiples of pi. Here's an x-intercept at negative 2 pi, negative 1 pi, 0 pi, 1 pi, and 2 pi. The domain for this function is all real numbers. This curve continues to the left in this same pattern all the way to negative infinity, and it continues to the right in this same pattern all the way to positive infinity. The range of this function is from negative 1, that's the lowest point on the graph, all the way up to positive 1. That's the highest point on the graph, and that is inclusive. This is a continuous periodic wave. A periodic wave means that it repeats itself over a certain period, and the period that the sine function repeats itself over is 2 pi. If you look right here at 0, the sine function goes up, comes back down, goes all the way down to negative 1, and comes back up. Then, at 2 pi, it will repeat that process, up, down, all the way down to negative 1, and back up. Every 2 pi, it repeats itself. Look at negative 2 pi, it goes up, down, down, up to 0, so that's a distance of 2 pi. Then it goes up, down, down, up for another distance of 2 pi. So the period of the sine function is 2 pi. Now, the next thing that we're going to do is we're going to actually draw the sine graph. We're going to graph it on our graph paper. So what I've given you in this video are the steps. I'm going to actually come over here and I'm going to actually do these steps for you so that you can see it, and then you can model these steps on your own. The first thing that you need to do is draw your x and y axis. So when I draw my sine function, I'm going to draw my x-axis. That's where my theta is going to be. So I'm going to draw my x-axis. And then I'm going to draw my y-axis. Okay, so this is going to be theta. And this is going to be the sine of theta. Now, remember the period of the sine function is 2 pi. So we're going to label our x-axis, or our theta axis, with 0 and 2 pi. And I'm going to come out here and label this 2 pi. Whoops. 2 pi. Now, the next thing that we're going to do is we're going to mark halfway in between 0 and 2 pi. 1, 2, 3, 4, 1, 2, 3, 4. So 1, 2, 3, 4, halfway in between 0 and 2 pi. I'm going to mark that, and I'm going to label that pi, because if I add 0 plus 2 pi, that gives me 2 pi, and then I divide it by 2, it gives me pi. So the average between 0 and 2 pi, the midpoint, is going to be pi. Then I'm going to mark halfway between 0 and pi, and I'm going to label that pi over 2, because 0 plus pi divided by 2 is pi over 2. And then I'm going to mark halfway between pi and 2 pi, and I'm going to label that one as 3 pi over 2, because pi plus 2 pi divided by 2 is 3 pi over 2. Then I'm going to label my y-axis from negative 1 to 1. So I'm going to put negative 1 and 1. And then I'm going to begin graphing my sine function. I'm always going to remember that the y-intercept of my sine function is 0, 0. And I can also look at my unit circle and see that the sine of 0 is 0. From the unit circle, we can also make a table. So if you have your unit circle, I'd like for you to look at it right now. If you don't have your unit circle with you, then I'd like for you to pause this video, go to your notebook, and get out your unit circle so that you can come back with me and see where the points on this table came from. The points on the table come from the unit circle. If I look on my unit circle and find an angle of 0, I can see that the sine of that is 0. If I look and find an angle of pi over 2, I can look and see that the sine of that is 1. The sine of pi is 0, the sine of 3 pi over 2 is negative 1, and the sine of 2 pi is 0. So these points on this table all come from my unit circle. So I'm going to plot these points. 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and 2 pi, 0. And then I'm going to connect these with a smooth, continuous wave. This is one period of the sine function. Now, if I want to graph 2 periods of the sine function, then what I need to do is I need to label in the opposite direction. So I'm going to label 0 and 2 pi. 1, 2, 3, 4, 5, 6, 7, 8. So here's my 2 pi right here. Yes, you can barely see that if I put it there. That's negative 2 pi. If I scoot this way just a touch, you might be able to see it better. So 0 to negative 2 pi, halfway in between there is going to be pi. Halfway from negative pi to negative 2 pi is negative 3 pi over 2. And halfway between 0 and pi is negative pi over 2. So I've labeled them in the opposite direction. Now this time, the function is just going to continue in its pattern. So since it's coming up, it's now going to go down. So the sine of negative pi over 2 is negative 1 from the unit circle. The sine of negative pi is 0. The sine of negative 3 pi over 2 is 1. And the sine of negative 2 pi is 0. And I can continue that graph by connecting it with a smooth, continuous curve. This looked a little bit too straight right here, so I'm going to erase that and do it over again, because this is a curve. It's not a straight line there. Okay, and that's my sine function. Now remember, arrows on the end, because this function does continue. It does not stop here. It does keep going to the left and to the right. All right. The next thing that we want to do is graph the cosine function. So let's look at the cosine function and see what its properties look like, and then we'll graph it. The function notation for the cosine function is f of theta is equal to the cosine of theta. The y-intercept for this function is 0, 1. That's a difference from the sine function. The sine function, the y-intercept was 0, 0. This function, the cosine function, the y-intercept is 0, 1. The x-intercepts are the odd multiples of pi over 2. Negative 3 pi over 2. Negative 1 pi over 2. Pi over 2, 1 pi over 2, and 3 pi over 2. The next one here would be 5 pi over 2. So the odd multiples of pi over 2 are the x-intercepts. The domain for this function goes to the left forever, and it goes to the right forever. So it's all real numbers. The range for this function, like the sine function, is from negative 1 to positive 1, inclusive. And again, this function is comprised of continuous periodic waves, which means that it's going to repeat itself every 2 pi radian. You can see here that at negative 2 pi, we're up at 1. We come down to negative 1, up, back to 1. Then it repeats itself, down to pi over 2 at 0, down to negative 1 at pi, 3 pi over 2, 0, and back to 1 at 2 pi. So let's graph the cosine function. We're going to do this one very much like we did the last one. There's just a few differences. So the first thing we're going to do is draw our x and y axis. And let me scoot back because I drew that in a different place. So here is my y-axis right here. So this is going to be the cosine of theta, and this is theta. Now I'm going to label my axis because the period of the cosine is 2 pi. I'm going to label this 0, 2, 3, 4, 5, 6, 7, 8. I like to use 8 because it divides nicely. Okay, so there's 2 pi. And now I'm going to mark halfway in between 0 and 2 pi. 1, 2, 3, 4. 1, 2, 3, 4. I'm going to mark that and label this pi because halfway between 0 and 2 pi is pi. Mark halfway in between 0 and pi. That's pi over 2. And mark halfway in between pi and 2 pi, and that's 3 pi over 2. Okay, now I have my labels on my x-axis. The next thing I'm going to do is label my y-axis. I'm going to label it from -1 to +1. I'm going to remember that my cosine function starts at 0, 1. This is the y-intercept of my cosine function at 0, 1. So I'm going to graph that first. Then, again, hopefully now you have out your unit circle. If you don't, stop the video and go get your unit circle so that you can see where these numbers come from. From the unit circle, we can make a table. 0, 1, that's this y-intercept. Pi over 2, 0. Pi, -1. 3 pi over 2, 0. And 2 pi, 1. This is my sine function, so I'm going to connect these with a smooth, continuous curve. And this is like kind of a cup shape here. Okay, I'm going to do the same thing going in the other direction. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm going to scoot a little because you can't see that. So let me scoot this way just a touch. Okay. And let's try that again. 1, 2, 3, 4, 5, 6, 7, 8. So this is -2 pi. Halfway in between 0 and -2 pi, 1, 2, 3, 4, is -pi. Halfway between 0 and -pi is -pi over 2. And halfway between -pi and 2 pi is -3 pi over 2. This function is going to continue in its pattern. So from here, it's going to come down to -2 pi. It's coming down to 0. Then it's going to go down again. At -pi, it's going to be the value of -1. Coming back up, -3 pi over 2, the cosine is 0. And then up again at -2 pi, we have a cosine of 1. I'm going to now connect these. And here is my cosine graph. Now these two graphs look a lot alike. The difference is the y-intercept. Notice that the y-intercept of the sine function is 0, 0. The y-intercept of the cosine function is 1. That's the way that you can tell the difference. And then the cosine function, let's start with the sine. The sine function starts at 0, 0, goes up, down, down, up. And the cosine function starts at 0, 1 and goes down, 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 up. And that's how you can tell the difference.